Hey everyone, Noah's Irby here. This is one of a series of short videos where we look at some variations in game theory on the prisoner's dilemma. If you haven't watched the video on the prisoner's dilemma itself, you may want to start there, but if you're ready, let's get going with Stag Hunt. Now, the Stag Hunt is sometimes referred to as the assurance game or the trust dilemma. It was first described by the French philosopher Jean-Jacques Rousseau in his Discourses on Inequality. And in its original formulation, the stag hunt goes something like this. A group of hunters has tracked down a large stag and found it follows a particular path. If they work together, they'll kill the stag and they'll all eat well. If they're discovered, the stag will flee and they'll all go hungry. The hunters all hide along the side of the path and time passes. The stag will eventually show up, but they don't know how long they're going to have to wait for it or when it will appear. Time passes, and one of the hunters sees a hare or a rabbit moving along the path. The rabbit will feed one person, but not the group. If the hunter leaps out to kill the hare, the hunter will eat, but the trap will be wasted and the stag will flee, leaving the other hunters without any food. The dilemma is one that if the hunter waits, they risk one of the other hunters killing the hare. From this perspective, or from the perspective of the individual hunter, the risk is thus twofold. The stag may not appear, or another hunter may ruin the trap and get the rabbit for themselves.
Be very, very quiet. I'm hunting rabbits.
In game theoretic terms, our payoff matrix looks something like this. Remember that the larger the number here, the better off we are. Observe that in this version of the prisoner's dilemma, there are actually two Nash equilibriums. One that's risk dominant when we hunt the stag, and the other that's risk adverse when we hunt the hares. But only one of these Nash equilibriums is Pareto optimal, suggesting that the coordination between individual actors should lead to the preferred outcome. Because of this, the stag hunt is often called a coordination game or sometimes an assurance game. The primary obstacle is not the threat of defection because of competing incentives, but simply of finding a way to coordinate strategies and choices between actors. The Bach-Stravinsky game, examined in another video, is another coordination game. The examples of the stag hunt can be found in the natural world, for example, among the carousel feeding methods used by Norwegian orcas and black-seed bottlenose dolphins, in which the predators work together to herd fish into a tight ball before taking turns feeding on them. In international relations, we see the stag hunt often used as a way to describe problems of coordinating strategies to address climate change in international negotiations, like the COP25 in Chile. So that concludes our very brief overview of the stag hunt. Be sure to check out the other videos in this series which look at other variations in game theory, including the game of chicken and the volunteer's dilemma. Thanks for watching. Bye.